guys, it's Miss X Storm, and I'm going to go over this angle bisector activity because some of you are having a little bit of trouble getting this to work out right for you. So I'm going to do it kind of quickly, so you're going to want to use your pause button if I go too fast, okay? We want to show that the bisectors of the three angles, that's how you know it's angle bisectors. It says it up here too. The three angles of a triangle all meet at a single point. Use the buttons below to be guided through the proof. Next step. Click the new point icon on the toolbar and then make 3 points to create points A, B, and C. And I'm going to go ahead and tell you now that I don't want you to end up with an equilateral looking triangle. I want it to look more scalene. Next, select the line segment tool and click on your points. And it actually wanted us, it's got them labeled A, B, and C. To label them, I should have labeled them, but it didn't. It's okay. Alright, next step. Now select the angle bisector icon and create the bisector of an angle. Select the 3 vertices of the triangle in an appropriate order. So if I want to bisect this angle, I'm going to click on that as the vertex, and that gives me my angle bisector. I want to bisect this angle, that's going to be the middle point. So click, click, click. And you've got to do all 3 angles. So I need the angle bisector here. Click, click, click. Okay. Now, if you move your triangle around, you should have a point of concurrency. This is actually what the next step tells you to do. Okay, and you can make it so that it's not looking equilateral here. Alright, next step. Notice that the 3 bisectors all intersect in a single point. Choose the select icon here and drag the vertices, and that's what I just did, to see that it's true for any triangle. Alright, so for any triangle we have the 3 angle bisectors intersect at a common point. It's called the end center, right? Be sure you have not an equilateral triangle. Since our statement on angle bisectors meeting in a single point seems to be true for every triangle, we want to see a reason why it has to be true. We want an argument that we can turn into proof. Next step. Select the new point icon and create a point inside the triangle and on one of the angle bisectors. So inside the triangle and on the angle bisector. You have choices. It could be here, it could be anywhere inside the triangle, but on one of your angle bisectors. It does not matter where, as long as it meets those 2 criteria. That's all it says do there. Click next step. Select the perpendicular line icon and drop a perpendicular line to one of the sides of the bisected angle. Okay, by selecting the point on the bisector, then one of the sides of the angle. Okay, so this point is on this angle bisector, so we're bisecting this angle. So we want a perpendicular from that point on the angle bisector to one of the sides of that angle. So it can either go to this side or it can go to this side. I'm going to have it come to this side. So what does it say do? Selecting the point and then the side. So I'm going to click the point. Did I click it? And then the side. Now I got to do that again. Let's see. The point and then the side. There we go. Okay. Now we're going to do next step. Select the intersect icon. It even shows you what it looks like right there. And create the point where the side and its perpendicular line intersect. So that's that perpendicular line we just created. This is the base of the perpendicular. That's all we're doing, so it should look like this. Next step. Select the circle icon and draw a circle by first selecting the point on the angle bisector. That's this point. I just clicked on it. Oh, look, there's a circle. And then selecting the point on the base of the perpendicular, that point you just created there. Next step. Notice that the circle is also tangent to the other side of the angle here. This is because a point on the angle bisector is equidistant from the nearest point on both sides of the angle. Okay, not terribly important there. Now select the select icon and drag the point on the bisector until it is also on a second bisector, which is your point of concurrency. Okay, so I moved this point that was there to my incenter, my point of concurrency. Hey, look, there's my inscribed triangle. Now, this point is equidistant from sides A and B. Now, if I move my triangle, actually, okay, hey, it is equidistant from B and C. Okay, so it's equidistant from this side and that side. And because this triangle is where I had it, okay, it is also, this is the radius, maybe, well, yeah, that is the radius from this point to here. Okay, now if I change my triangle, it's still not inscribed. That's why, listen carefully, that is why it was important to start off with a not equilateral looking triangle. You wanted to start off with a scaling looking triangle. Okay, so if you need to go back and redo your triangle, then go back and do that. But this is your final step. Okay, and this is what I want to see. A triangle that's not equilateral in an inscribed circle. All right, I'll be looking for your work. Bye-bye.